Good morning, everyone. My name is Bill Roth with VMware. I'm your host today for our webinar, No More Blind Spots, Delivering Containerized Services Reliably with PKS and Wavefront. Our speakers today will be my esteemed colleagues, Steve Tegler, Senior Director of System Administrations with the Cloud Native Applications Business Unit inside VMware, as well as a thoroughly engaging Wavefront discussion and demo with Pierre Tessier, who is our systems engineering leader with the Wavefront team at VMware. A couple of housekeeping items, and then I'll turn it over to Steve to take us into the content. We do have both a Q&A window and a chat window. Please make sure that you fully utilize those. We have staff from both teams standing by to answer your questions. This session is being recorded, and we will send both the recording as well as the slides to all the registrants starting tomorrow. So, and with that, what I'm going to do is transition to our agenda, and I'm going to turn control over to Steve Tegler. Steve, you now have control. Take it away.
Thanks, Bill. Appreciate it. Here we are with the agenda. So my name's Steve Tegler again. I work on PKS exclusively here at VMware. I'm gonna start off the conversation giving a brief overview on PKS. We did just do a webinar on that a few weeks ago. I believe we have the link in the slides later on. Then the majority of the presentation and demo will be with Pierre. So let me hop right into this. So one thing I want to highlight here is kind of the need for Kubernetes if some of the folks on the line are not aware. You know, historically we've had application developers having to, sometimes configure infrastructure directly. So this could be anywhere from the operating system configuration to virtual machines, compute, network storage. And the reality is they didn't want to be bogged down with some of those tasks. They want to be focused on writing code. So if we enter Kubernetes here, what Kubernetes gives them is this really neat abstraction so that they can design their application, they can upgrade their application, they can monitor and so forth using Kubernetes primitives and Kubernetes constructs. And fundamentally, without getting into the details, it's just easier for them to live in the Kubernetes space. Now, one thing that isn't necessarily talk about is the fact that Kubernetes doesn't provide any sort of storage functionality or network functionality, but what it does do is give you a way to define that functionality. So what happens is that eventually, after Kubernetes is installed, you need to have those ties down into your infrastructure. And so again, Kubernetes gives the tools that the app dev teams they want to use. There's a lot of functionality in there that helps them build their apps. They like to use it, but they don't necessarily want to operate it. And again, go back to integrating it with infrastructure. And so with PKS and Kubernetes, let's talk about those two. So again, Kubernetes is about application or even potentially container scheduling. The scale of that application, the resilience of the application, the day two, the updates of the app. So you can think of Kubernetes as really the desired state of the application. Now, if we take a look at PKS, this is about the actual Kubernetes cluster that those apps are running on. So this is creating that Kubernetes cluster, scaling the cluster, the resiliency of the cluster, and the day two of the cluster. Think of PKS as the desired state of all of those Kubernetes clusters. So this is a joint engineering effort between VMware and Pivotal. So we have engineers that work side by side with each other and produce the PKS software. So let's talk a little more specifically around that mapping. Like when we have to take Kubernetes and actually run it someplace, what does that look like? So again, we've got our application developer. In this case, I'm showing this individual wants to deploy an ELK stack. And what they'll do is they'll use those Kubernetes primitives available, and they will design and architect this application. Now, again, Kubernetes doesn't include any sort of storage functionality per se. It includes a way to define the storage. So what happens is that you eventually have to map all of these Kubernetes constructs down into your infrastructure someplace. And usually what happens is that there is a team or a group of people that are responsible for, number one, deploying Kubernetes, and then number two, mapping each one of those constructs down into your infrastructure. I'm generically calling this a platform operator. Now, what is key here, specifically with our VMware contacts, is we'll come in and they want to take those Kubernetes primitives and they want to map them into infrastructure that they already know. And so in that case, what we're really talking about here is taking those constructs and mapping them down into the software-defined data center and all of that technology. And so if we look at the cluster, like persistent volumes, those will eventually get mapped down into data stores. Load balancers, those will be created and implemented with NSX. And if you think about it from an app dev standpoint, they create the load balancer or ask for the load balancer, but no human being has to go do anything because we've got this mapping of Kubernetes down into the infrastructure. And of course, the other piece over on the right-hand side here is the application metrics. You know, if I'm an app dev, really what I want to do is get the metrics and the information out of my application. I don't want to necessarily deploy an application monitoring solution per se. I just want to be able to access that level of information for myself. So that is going to be done through the technology Wavefront, which we're going to spend some time on here in just a minute. So the other thing I want to highlight here is, as a platform operator, you know, don't spend too much time really trying to understand each and every intricate detail of an application. Because the minute you learn a given application that the app developers are using, they're going to go deploy something else. So what the platform operator needs to do is really understand what are the features and functionality required by the apps, but not necessarily the intricate details of each and every app. So just a real brief PKS in the VMware portfolio here, everything in red. So if you wanted to purchase PKS, what you get is you get the PKS control plane. That will be responsible for deploying Kubernetes and mapping it down into the infrastructure. It includes a technology called BOSH, which is responsible for the entire lifecycle management of Kubernetes. It also includes NSX, which will provide all the networking functionality required for all these cloud-native workloads. And finally, we've got Harbor, which is a container registry that ships with PKS, and you can use that if you like. Of course, PKS runs on top of vSphere as well as public cloud environments. On the left-hand side, you see all of the cloud management solutions from VMware. Of course, Wavefront is right at the top. And what I want to do right now is pass it over to Pierre to drill into the details around Wavefront and Kubernetes and PKS. So Pierre, let you take it away.
Thanks a lot, Steve. I hope everybody can see my screen right now. Awesome, thank you. So we're going to talk about how does Wavefront help you when it comes to monitoring your PKS. How do we help you find those blind spots, if you will, and really help discover what else is going on. And I want to first talk about the challenge of container monitoring. And this is not just for PKS. It's not even just for Kubernetes. It's really for any containerized style project or initiative that you're undertaking. By nature, containers are ephemeral. They go up and down often. They are quite short-lived. And this ephemeral nature of the containers provides some challenges for any monitoring platform out there in the world, because the way we do monitoring platforms is we use key value stores as a database. And part of your key is oftentimes where the data come from. Where did the data come from? It came from this ephemeral thing, a container ID, which lived for 3 hours and then came back down and got recycled and brought back on. The beauty of using Kubernetes and many containerized environments is the ability to scale up and down your pods or your containers as workloads increase, so you could work with your application of that nature. Well, when these containers come up and down, they create this issue of high cardinality with your data entering your time series monitoring platform. Wavefront has actually quite a few patents around this. We spent a lot of effort. We were born in the cloud. We were born in container monitoring. Our roots come all the way back down to before containers were a thing, and this is how Google did it. They called it Borg back then, and they created a platform called BorgMon, and that's really where our roots really start from. And we built a lot of functionality and features into our platform to help you avoid, especially blind spots. And what are blind spots? When you do a mass deploy, especially on larger environments, you might be taking up and down 1,000 containers in a single instant. When you get 1,000 brand new containers, each with 50 new metrics coming into a time series platform, oftentimes the platform can't keep indexing at the rate you're sending in the data, and you go running blind for a while. We've worked with some customers, and they go for as long as 15 minutes blind using other platforms. That's unacceptable in Wavefront. We've done technologies behind the scenes to make sure that as soon as you commit brand new IDs, brand new things to us, you're going to see them in seconds. We've done some high-scale tests around this. We're going to announce them at VMworld, but we're happy to say that even under massive workloads, hundreds of thousands of containers, you can still go without running blind when you do these big deployments. So what is Wavefront? Well, Wavefront is for the app devs. It's for the SREs. It's for the DevOps. Wavefront creates those rich visualizations that we're looking for using a unique way to approach it. And instead of boxing you into how you view your data, we open it up and we solved a lot of it for you with Wizards. We provide that rich visualization framework for you, all backed by a very powerful query language, and ultimately allows you to ask real questions and get real answers. No more do you need to robot your way into, is my system up or down, but you can really see trends and events happen over time. We are absolutely inspired by those web scale platforms. I already mentioned our roots came from Google. Our querying capabilities actually came from Twitter. And we took the best of all these worlds where our founders came from, and we put our minds together and we came up with Wavefront. And Wavefront is really meant to be a real-time streaming data processing engine for your cloud native applications. And Kubernetes is a great example of that. Why are we different from others? Well, one, we have unrivaled scale. Wavefront today ingests over 5.5 million pieces of data per second. That's a massive volume. That's what we do today for our customers in production. We have some customers that do nearly 1 million by themselves per second. And if you want to think about this other way people measure, they measure this number per minute. So we'll say we do well over 300 million points a minute going into Wavefront. That's scale. But that's one thing to pump it in. We'll also allow you to query it back out millions of points per second. And we can show you in our platform how you can write queries that go after over 1 million raw data points and they return in under a second with computations done against that data. Wavefront will never roll up your data. And what do we mean by that is other platforms, after a week, you're collecting data maybe every 60 seconds, that becomes 5-minute averages. And after a month, your 5-minute averages become hourly averages. You lose the resolution of your data as time moves on. And we all work on big applications. We write these big monoliths or big microservices frameworks, and we find an issue with one. You're not going to fix it in a week. It might take you many weeks before you have a fully deployed and ready to go fix, sometimes months. But if you lose the resolution of that data, how do you really know what you've created really did indeed fix it? You would have to be exporting all the time to keep that raw detail. And Wavefront, we do that for you. We talk about real-time iterative investigation. That's really what our power is. As you augment your data, as you add additional cardinality to it so you can slice and dice it, you get to use the Wavefront platform to understand the aspects of your information. Drill down to the specific item that is causing you pain. And being able to do this in real time, Wavefront, we save people thousands of hours in unplanned outage effort because we give them the tools to iteratively investigate why a certain problem is having and pinpoint the root cause very quickly. We wrap this up with intelligent alerting. It's one thing to be able to monitor, but you need to be told when things are going because you're not looking at a screen all the time. You're not always looking at the charts that matter. So being able to take the same logic that we put into those complex charts to create those great pretty pictures and having that back our alerting system is powerful to many people. Alerting in Wavefront is not a separate system. It is not another black box that you can't control. It's anything that you can visualize can be alerted in Wavefront. We allow you to take the full power of our platform and use that on our alerting stack. And speaking of stack, we say this, and so does everybody else, full stack business correlation and understanding, but we mean it. Our machine does it. We don't expect you to stand up 100 charts on a dashboard and have a human being look at every chart to spot what's correlated with another. You ask Wavefront the question, what correlates to this? And we will give you an answer. That is really the power of machine correlation, finding those answers for you, finding the needles in the haystack of the information that you have. And ultimately, when you do that, we help you answer those smarter questions. Now, when you team this up with PKS, if you're my kids, it's a happy meal, right? They love this because really what we're doing here is we're combining this great power of Wavefront with an easy to deploy platform for your Kubernetes, an easy way to match the Kubernetes components to your underlying infrastructure, and an easy way to monitor the entire thing all at once. We do offer free trials with Wavefront as well. Certainly invite you to try it out for yourselves. And we do have, we blog about this and we talk about it all the time. But out of the box, and we'll show this, is as soon as you turn this on, you get some rich information immediately. Now, what do other customers say about Wavefront? And here's a couple of great quotes for you. I'm going to talk about a couple of them. We have a large financial institution. They're actually just onboarding that PKS journey. And they've gone from nothing 3 months ago to now they have, they're not quite at 5,000 containers in production, but they're well over the thousands of containers in production running today, all monitored with Wavefront. And it was really easy for them to get up and running like this. So it goes to show how some of these more forward-leaning organizations, and they've decided, they made that decision that we are deploying everything on PKS. We're moving away from monolithic. We're moving away from creating instances and wasting money by spinning up VMs that are just wasting resources. And we're going to do this right on PKS. We're going to take full advantage of our hardware. We're going to enable the developers to do what they want to do. And their ramp up has been nothing but just amazing. And on the other side, you've got Box, a traditional, a SaaS organization. And they have thousands, 18,000 over containers in production that cycle nearly every single day. And they depend on Wavefront for all their monitoring needs. Everybody at Box who's an engineer or in operations has a Wavefront login. And they all log in at least once a week into our platform to see what's going on. Most of them log in multiple times per hour or are viewing information all the time in streaming mode. But even the developers, as they do stuff, they get immediate insights on what's going on because they see their application metrics being correlated with the underlying infrastructure for it immediately. And speaking of application metrics, it's one thing to say, hey, you integrate with Kubernetes, but I'm running Nginx and I've got Kafka and I've got some MongoDB in there. This is a small representation of the various tools that we integrate with a couple mouse clicks into Wavefront. And we're going to show this a little bit as we go and show off the product here. So with that, whether you're doing application stuff or you have maybe other monitoring tools, maybe you even do some logging and you're putting a lot of effort into logging, but it's not a really cost-effective way to do real-time monitoring, Wavefront can help alleviate those. And we can combine that with the power of a platform like PKS to help you deploy these things very quickly. And with that, I'm going to take a quick pause here, and we're going to actually launch into a demo. What does this look like? What is this experience like when we use Pivotal Container Service? And if you use PKS, you may be familiar with this screen. This is Ops Manager. This is how you kind of start off with. And for PKS, you're going to need these two tiles, the vSphere tile, which is the underlying infrastructure, and you will have the Pivotal Container Service, which leverages that infrastructure via BOSH to essentially create your componentry in there. Now, with Pivotal Container Services, effective version 1.1, which was released earlier this summer, when you go inside of this tile, you'll be presented with your various configuration options, and there's a monitoring option or tab down here. And when you click on that, it's as simple as just clicking on yes. You supply your Wavefront URL and your access token. These are available inside the Wavefront product itself. And finally, PKS will create some alerts within Wavefront about the underlying infrastructure, if there's any problems with it. PKS manages these alerts for you, so you could provide a set of email addresses here to be alerted of it. Mind you, you can go also in Wavefront and modify these alerts thereafter, if so desired. Once you click Save here, you will need to go back to the installation dashboard for Ops Manager. And then you will go ahead and apply your changes. Now, I've already done this before. This is a process that can take a few minutes to run, depending on how many clusters and how large they are. But once this is done running, all your clusters and any future cluster that you create, and I mean Kubernetes cluster that you create, will be sending data to Wavefront. That's really all it is. So how does that work? Well, here I've got some clusters that are sending data to Wavefront, and this is Wavefront. This is in the integrations section of Wavefront. There's a Pivotal Container Service integration that's running. And you can see we have all kinds of different metrics here that we provide. A lot of this stuff is called Heapster, and then we get into what we call cube state metrics. These are all very popular in the Kubernetes world, and they all come in automatically. And ultimately, what you get out of that is you get a dashboard that looks like this. Okay, I've got numerous different clusters behind the scenes. Sunny Labs Dev is the one we're looking at right now. I've got Prod and Stress and a couple other longer named ones. Every cluster, when you select them, will go ahead and switch your view of what you're staring at. We give you a good high-level overview of what's going on. And as I scroll, we're actually going to refresh all these charts here in real time to pull it up. I could see here, just taking a quick look, I've actually got one node who's under a lot more pressure than all my other nodes in my cluster. This might be interesting that we could go investigate later on. I'm going to return back here to the top. A lot of people, when they work with Kubernetes, they work with the constructs of namespaces. One great thing about namespaces and PKS is that we will automatically create an NSX subnet for each namespace to give you further isolation and segmentation for what's going on. This is important since typically we build little walls around each namespace. So oftentimes when we're talking about namespaces, we want to drill into information by namespace itself. So we can go ahead and say, hey, only look at that one application we've got out there called PlaneSpotter deployed in its own namespace. So now when I do this and I look at my various charts in here, and we get to the pod section, all my pods will be specific for that namespace. So now we're really just drilling into what matters. I'm going to continue on right here. We're going to look at CPU usage rate. And I could see I do have a pod that maybe it's reacting a little bit odd. It's certainly seems to be consuming a lot more CPU. With Wavefront, it's easy to kind of dig down to what's going on with these. I'm going to go ahead and just click and zoom across. Click and drag, to zoom in. And then we could push that zoom to all the other charts in my dashboard. So now they're all staring at the exact kind of slice of time. When you hover a chart or when you hover a line, we kind of focus that line and we dim out all the other lines. If you go ahead and click on a line, we're going to do that exact same effect to all the other charts in your dashboard. And if you hold down Command, we're going to go ahead and add those additional selections for you. Now, what I was doing there is I was selecting the nodes behind the scenes that are responsible for that, okay, which ones they are, and the sources, if you will, behind each one. Maybe I found something interesting and I want to share this with my colleagues. Every single one of our chart and dashboard options, we've got this link icon, a way to quickly share this with your colleagues. You click on that, we generate a short URL. And what you get from that URL, it's not a static image. It's a fully functioning dashboard. Pre-zoomed in that same slice of time, and those same exact machines are pre-selected for you. So you're looking at exactly what you were looking at before. There's no more question of, did you mean node 132.16.0.4 or 0.6? I can't remember, I'm sorry. Or did you mean 9 a.m. Central or 9 a.m. Eastern? right? There's no more ambiguity with it. We help you get there very quickly. This is certainly important on large teams and teams spread out, not in the same building or not even in the same time zone or even the same continent for that matter. And it does happen in our world. Now, we've deployed Kubernetes. We're monitoring Kubernetes. We're understanding the nature of what's going on with our Kubernetes environment, and we've got the power of Wavefront to help us get there. But it's one thing to monitor Kubernetes. We still need to do more, right? I've got here an app, and I've talked about it. I mentioned it already. It's called PlaneSpotter. PlaneSpotter is a simple little web app that we've built to kind of highlight the the microservices way that we build apps today. This app doesn't do much. It's kind of interesting. It goes out and it tells you what aircrafts are going on where and who owns them. I, for example, like to fly Delta Airlines. They are a local airline for me. And I could go in here and I could see what's going on. Delta's got various planes airborne in the air right now. Click on them. And from that, it'll tell me where this plane is and a little picture of that one. And if you fly on one of these, I feel sorry for you. They're tiny planes and they're really tight. And we can even click on that and we get a little location. This is where the plane is in the world as of about 5 minutes ago for FAA security reasons. So really handy little app we've built. And the architecture for this app kind of looks like this, okay? Because we deployed a load balancer as part of one of our YAMLs for the app, we get automatically the NSX load balancer with PKS. This is great because we control security at that level. Instead of having to do more stuff and all these other deployments, we have an actual piece of, in this case, virtual object that we control through the NSX manager. The app will deploy Nginx here at this tier, where we call the web tier, one or many. And this is really just to do some load balancing and some serving of static resources that are provided by the application. There is an API server behind the scenes. This is a simple Python Flask application. And the API server will make requests to both a MySQL database as well as a Redis in-memory data tier to go get information brought back up to the front end. Meanwhile, we've got another Flask application running right here, which is going out and getting real-time position information from an FAA service every 5 minutes. And it is filling out our Redis database with this information. So together, it's kind of our microservices app. And really, it's made of about 5 different YAMLs. So if you're familiar with Kubernetes, you deploy things using YAMLs. This is what it's really made up of. And every one of these YAMLs contain the information on how to be able to be monitored. Now, one of those is Nginx, like I mentioned earlier. And we do have an Nginx integration as part of the Wavefront integrations page right here. Here's a list of just a couple of them. And when I click on this Nginx integration, we could see here some setup instructions on how you get it set up. We have some more on how to do it in the container world. And ultimately, you get a dashboard, which looks like this. Nginx dashboard. And what I get here, it's every single one of my systems that are currently reporting. And if you look at the legend, there's a tab, there's a column there called ENV, and you'll see that matches the same things as those Kubernetes clusters that we had earlier. But this is great. I've got an Nginx dashboard. I've got a Kubernetes dashboard, but they're two different things, right? So Wavefront, we want you to build what we call is the full stack view. And you could walk into any chart. We offer various different ways to do this. Here's one easy way I like to talk about is you go inside of a chart and down here, you start typing in the name of another dashboard. You could go ahead, select it and then insert it to that new dashboard or save it to a brand new one. And this is kind of a way we would like to help you demonstrate to build them out. But truth be told, building out any of these dashboards is super simple in Wavefront. You could just say create new, and it's a great drag and drop experience as well. In the end, I've built that PlaneSpotter dashboard. by simply literally went to a bunch of different dashboards and I inserted charts into them and I built out this framework right here. I then put it into edit mode and I did a little bit more dragging and dropping, renamed a couple small things. And ultimately what I got is what matters to me when I'm looking at PlaneSpotter. This dashboard allows me to look at my different environments. I don't think Prod's getting any activity right now. You can see it's actually got 0 activity on it. We didn't really tell the world yet we're in Prod. We're still running tests on dev. And you can see we even had a hiccup right here in our testing. Across the top here, I've got all these short links, and these represent all the various sections here in my dashboard. So the front end would be Nginx. And then we have the Redis tier right here as well, and all kinds of information around that. Interesting to note about the Redis tier is that because this is saving the information from FAA, when I switch this to a one-day view, you could kind of see the planes going in and out of travel, if you will, as they go. Where you have very few flights at night, but you got a lot more during the day. And then we continue on. We've got a MySQL tier and so on. But I'm going to come back to the top and look at this. And we're going to come back to that first question we were talking about. And it's this right here. CPU rate. We seem to have a node that was maybe a little bit under pressure, particularly under compute. And right here, part of our PlaneSpotter app, we can kind of see that smoking gun really quickly, right? We've got one guy who's consuming significantly more compute than all of our other pods within our environment. And looking at the legend, this guy is called MySQL-0. It's obviously part of our backend data tier. And I'm looking at this and then, 6.1 commands per second, and we're suffering compute. Maybe we have a problem. Maybe we don't have the right indexes on our database. Maybe we just need more compute. Maybe it is what it is, right? There's tens of thousands of planes in the world, and the database has to have them all, and it's getting pounded all the time with queries to go get information out of that. Maybe MySQL is not the right component for this task. Maybe we should be using a different kind of a data tier. Is Mongo the right one? But it allows us to understand this quickly and see where we need to go. I'm going to go ahead and go to the pod section of this dashboard. And this is really just the data that we're getting from Kubernetes. And just underneath that, we have pod containers, which is really echoing that same statement over again to me, is that we do have a problem with that MySQL tier. That specific container itself is the one taking up all of my compute. Able to put this together really quickly. And you can see here with this experience, I'm going to sit here and pause how we load up all these charts as well on demand to help you give you that immediate view. Really get some nice, rich information delivered to you and to all our customers is important for us. Now with that, I knew there was a lot of interest for this webinar, and I seen the QA and the chat panel really start to fire up. So I wanted to cut myself a little bit short to make sure we really got a chance to answer all of the questions in the QA area. So Bill and team, if we want to open up the lines and allow people to ask some questions, I'm certainly happy to answer anything that comes up.
Indeed. Thank you very much. And I know there's been a ton of, if you want to see a super active chat, I don't know that we've ever had a more active chat in my career during a webinar. And so make sure you sign up for our self-service trial to answer a lot of your questions. And that, of course, would be at wavefront.com/sign-up. Pro tip, as the kids say, we're actually running a promo so that if you'd like to enter our promo for getting a free $500 JBL speaker, go to wavefront.com/500 and get data flowing. So for those of you who have been very active in the chat, a great way to sign in and reward yourself potentially. So there was a question around logging, and I think I think what we can answer right now is maybe you could talk about sort of how would we pull metrics out of log files generally. Log Insight obviously a great logging product, but talk about our log integration in general.
Sure. So in general, regardless of what the logging platform is, we follow the same basic premise for all of them. And we will do what we call as Grok, G-R-O-K. It's a regex style, I don't want to call it language, but syntax, very popular in the world, made popular by the Elk stack in particular, but used by every logging platform today to look at your lines. And if we hit a match, we'll parse that line against the grok statement. And what we get out of that is something that can become a metric. So a really popular kind of use case way to look at it is maybe every time you get an authentication error into your platform, you write a log line out. And we see that log line come in. Internally, we increment a counter. And maybe in the past 30 seconds, you've hit this thing 68 times. So after 30 seconds, we will send a counter with a value of 68. And then the next 30-second block, you've done it 20 more times. So the next counter will come in at 20. And we will take care of sending that over. So what we're doing there is we're not passing the details of each authentication error. We're counting up the number of times they've occurred. There are other times where you might have a batch process that you run. And when the batch process is done running, it writes a log line that says, hey, I've updated 58 records. My duration was 3 hours and 28 seconds or something like that. That's two different metrics, and we will actually capture those two metrics from that one log line and write them out as what we would consider gauge metrics or values for a single point in time. I hope that answered your question.
I think that was quite thorough. Pierre, could you talk a little bit about PCF? Talk about kind of the interaction between Wavefront and PCF and how that might all play together.
You know, this is a PKS webinar, so I wanted to avoid it. But if the question comes up, we could certainly mention it. Now, I did look at this earlier this morning, and this is our dev environment. Unfortunately, somebody's playing around with my development environment. So right now, we're not flowing data, but yesterday we were. When you do PCF integration with Wavefront, you get 12 dashboards. It's actually quite deep. This is because of the way the PCF platform is built. They've got a lot of kind of hanging components off it. Wavefront integration is another tile you deploy. It's a nozzle that sits on the PCF logerator, and it collects all of the metrics and flows them in. I'll check out summary. This is my favorite PCF dashboard, and I'm going to bounce myself to a one-day view real quickly. You get something that looks like this. Now, if your environment's all green, you are very happy. I doubt this is true for the world, but this would be a typical kind of dashboard that we ship with out of the box. Lots of high-level stats here, and of course, you could drill into any of the individual components of PCF to dig into the details and learn more.
That's good. Any specific considerations about PKS, kind of best practices that as you put this together that you want to talk about? And also, Steve, if you have any other kind of points you'd like to make as well.
I'll start off here a little bit. There's no one way to monitor everything. Every little thing has kind of its own way. We did break it down to kind of three main categories. There's two ways to pull metrics, or I'm sorry, to push metrics in. One of them we call a sidecar, the other ones we call it standalone. Those are ways that you do your deployments themselves, and we provide sidecar or templated images and deployment YAMLs to help you go down that path. The other way is to use a more popular, it's definitely popular in Kubernetes world, Prometheus. It's an open source software which emits metrics in Prometheus style. Wavefront, we work very well with that space, and we could suck it in. The beauty there is that you don't have to end up managing a lot of Prometheus silos. We take care of that for you. We, in fact, drop right into an existing environment, and we'll be able to suck it all into one big environment. Now, one thing I want to mention about containers is, like I mentioned earlier in my first slide, is the cardinality of your data explodes. And developers sometimes get scared to bring their cardinality up. The problem with that is they don't add the data that they need when they need the data. Right? You don't know you need something until you really needed it. We encourage people to use annotations and labels as part of their Kubernetes deployments to add additional context to everything they're doing. So that time comes when they do have a problem, they can use that context to get to the root cause of it quickly. Using other products and other monitoring tools, you're going to find that they want to limit your number of labels because cardinality becomes an issue with them. And with Wavefront, like I said earlier, it's not that of an issue. And we encourage our developers and our users to make heavy use of that, because that extra context really helps you when you need it. And you don't know you need it until you really need it.
Got it. I want to make sure folks know where to go. Wavefront.com/500 if you'd like to enter our promo, or if you'd just like to try Wavefront for free for 30 days, wavefront.com/signup. For PKS questions, you can see the URL there, and that will be put back on. You'll get these slides beginning tomorrow. Cloud.vmware.com, Pivotal Container Service, contact sales. Steve, maybe there's some question. There's an interesting question that you could potentially talk to. How would you compare PKS with other solutions out there? Came up in our chat.
Yeah, right. So, I think the biggest differentiation is, there is a big differentiation between day one, but more importantly, day two. So one of the big things is that there are some initial configurations you do with PKS. You basically, when you deploy on vSphere, you basically feed it the vSphere credentials. You feed it some information around where NSX is, and it will automatically go and configure all the links to those infrastructure products. So the initial setup is very easy done. It can either be done via a GUI, what Pierre showed in Ops Manager, where you just feed it this basic information. But once you have those initial connections done, the biggest differentiator for day one tasks is the fact that we can deploy multiple Kubernetes clusters versus like a single Kubernetes cluster per single PKS deployment. So I can go to PKS, I can say PKS create cluster, and create multiple clusters with a single command line. That's the day one benefits. The day two benefits are around upgrades and patching and so forth, scaling, right? And so from a day two perspective, if I wanted to increase the number of nodes in my Kubernetes cluster, I could very quickly go from nodes from 3 to say 5. And that happens merely with a quick API or CLI command call to do that. And as a part of the growth, like all the configuration is done automatically under the covers, including any sort of Wavefront integration that needs to happen. So again, think of that. You want to scale your cluster, single command, and you can grow it out at will. Final area, which also is day two, is around patching, upgrades, and failures. So if I wanted to go from one Kubernetes version to another, it's a very simple interaction to do that. All of this functionality is handled with a technology called Bosch that's embedded in the product. It's actually fairly mature. And then I guess finally failures. If a node were to fail, it's one thing to be notified of a node failure. For us, we actually go ahead and repair any nodes that fail automatically. So that's a big differentiation for us as well. And I'll pause right there.
Excellent. Thanks, Steve. Pierre, we had a question, I think, during the demo. Were you showing data in UTC GMT format, or was it showing data in the browser local time zone? Comments about that?
My default, because that's how I'd like to live, is to use my browser default. It is a user preference that you specify inside of Wavefront. You can say use my browser's time zone, lock it to a specific time zone, and that includes UTC. Excellent.
Thanks very much. Again, a reminder, wavefront.com/500 for the promo. So if you have any questions, please do feel free to ask them. I think one of the questions that comes up quite frequently is sort of, does Wavefront integrate with X? Well, the answer is yes. And we have if you go to wavefront.com/integrations, or you go to docs.wavefront.com, you can see we are now at more than 160 different kinds of integrations. And you are correct, Bill. We did roll out another about a half a dozen or so yesterday, in fact. We have another question. And so the question is, I think Pierre and maybe even Steve can talk about this. Where would I deploy Wavefront? and talk about, I think specifically what you would deploy, but would it be on the K8S master or node, or where would you talk a little bit about kind of the deployment for that?
So part of PKS is it takes care of doing the deployment for you. And really what it is behind the scenes is that it's a single pod that has various containers inside the pod, which go gather all the metrics for an entire Kubernetes cluster. So it's one pod per cluster. That's good to get you all your Kubernetes information. If you want to send application information, depends on what you're trying to do, but it's all handled as standard pod deployments. We don't do daemon sets or anything like that. And I want to put one more piece on that. A lot of times it's just, if it's part of your existing pod, will just be a sidecar container to it.
Got it. All right. Any more questions from the audience? If not, we are now at 50 minutes past the hour. As a reminder, wavefront.com/signup or wavefront.com/500. If you'd like to enter into our gala sweepstakes. Seeing no more questions, ladies and gentlemen, thank you very much for attending our webinar. As I mentioned, this has been recorded, and you will get a copy of this recording as well as the slides starting tomorrow. So for Pierre Tessier and Steve Tegler, this is Bill Roth of VMware. Thank you for attending today's webinar.